So given these two functions, supposedly one of them is continuous and the other is not. So continuous means that it has no holes or gaps or asymptotes. So let's see. First of all, graph this one and see what's going on. So y equals, put the numerator in parentheses, x is squared minus 6x plus 9. That gets divided by parentheses x minus 3. And then I'm just going to go to zoom standard. So this means it's going to go from negative 10 to 10 on the x-axis, and negative 10 to 10 on the y-axis. And that looks like a nice continuous function, but there's something going on at 3. So what's going on at 3? So if you trace and you put a 3, there's actually a hole in the graph right there. So for this one, the graph looks like this. Here's the 3, and then the graph is going along like this, nice straight line, and then it's got a hole in it, and then it keeps going. So it seems to be continuous, except there's a hole in the graph right there. Now this part is saying if x equals 3, make the y value 0. So that part actually fills in the hole, and this is continuous. All right, what's the difference between that one and this one? So let's graph this one. Y equals, clear out the old one, and then this one is x squared plus 6x plus 9, and then divided by x squared minus 9, and go back to the graph. Okay, that one looks different, and that is not continuous. So right here is x equals 3, and that one has an asymptote at 3. So this function goes down, and this part goes down to negative infinity, and this part goes up to positive infinity. And then this one is saying, oh, by the way, I also want you to put a dot where x equals 3 and y equals 0. So the difference is this one only had one small problem. It had a hole there, and then this filled in the hole, which made it continuous. When there's an asymptote, there's no way to fix that problem with one dot. There's still an asymptote. So this is not continuous.